Okay, let's focus for the mobile communication for a while. So I start with motivation, but I'm not showing for you any forecasts because, as we know, forecasts are forecasts, reality is reality. So I start with few. Wow, this is fast. I start with this picture. I'm not going crazy, at least yet, but this means that currently the data transfer in mobile networks is something like 18 times the data transfer in the whole internet at 2000. So this tells something about the growth rate on the mobile data. It's still growing fast, and it is expected to grow very fast also in near future. But let's not look at too much these forecasts because they are sometimes biased. The measurement data is not that much biased. Just another point. So how is the usage of the mobile data? If we think about the usage at 2010, which is just a few years ago, 1% of the users were using 52% of the data. So there were few super users, like my daughter who's sitting on Netflix and YouTube and so on. Nowadays, 1% of the users spend 10% of the data, and 99% of the users is using or consuming 90% of the data. Which means that this usage of mobile internet has become more evenly distributed between the users. So part of the huge growth is coming from this, from teenagers that are looking Netflix and YouTube. But anyways, and from this on, the growth is mostly coming from the increased data rates in connections. Number of connections is about to saturate. Share between the users is becoming more and more even. Okay, but motivation was there. Now, what has happened on the technology side? Let's look at that for a while. So evolution has been going from G to G, so it's kind of a long queue of strong promotion of new technologies. We started from 2G networks, which represent transfer from analog systems to digital systems, which were expected to be too complex, too costly to success. But as we know, GSM was pretty successful. 3G represented voice plus broadband data evolution. Originally, the killer application, which was voice and SMS for 2G, the killer application for 3G was expected to be video call. At least video call was a good candidate. As we now know, we have video calls, but through Skype, not dedicated video calls through a specific service provided by mobile network. But what became a killer application was internet, mobile internet. And when that was realized, the 4G efforts were started. And 4G has been designed mostly for broadband provision, mass broadband provision for mobile users. Now, at the moment, 5G discussions have been starting. This seems to be a little bit boring for 2G, 3G, 4G, 5G. And until 4G, always the change was on the radio. The radio's access methodology was becoming a little bit better, providing a little bit more services. We were switching from circuit systems to packet systems and so. But now, somehow, this is not going to sell anymore because we can't improve that much radio efficiency. But we need to do somehow a disruption on this evolution, and this disruption will be just part of the 5G. which will be mostly well-combined usage of the existing Gs, so 3G, 4G. And let's look at that, what kind of 5G technologies there are. I'm not going all different options through. I don't have time for that. And on the other hand, some technology components are actually such that they are somehow not, for me, they are not kind of revolutionary technologies. But let's focus on one example technology that is, to me, more or less revolutionary. But before going to details, we think about a little bit the means, how we can reach higher rates, more capacity that we need. What are the means? And for that, I have been, I'm presenting just one equation. Most of you are probably engineers, so I hope that this is not too much for you. And this is showing basically what we would need for the higher capacity. We need stronger signals, which means that either we need to transmit more power or we need to bring transmission units closer to the users. Another option is that we improve system efficiency. That is embedded in the one letter there, one parameter. Actually, there is tens of thousands of papers written, research papers, on how to improve the efficiency of the radio. Multi-antenna methods are there. There are different scheduling methods. Lots of different methods have been created to improve the efficiency of the radio. But somehow, we are not on the limit, but it is foreseen that by improving the system efficiency only, we don't get that much gain anymore. Then what we have left there is the bandwidth and the number of users. And what is bandwidth? It's frequency bandwidth defines the width of the road, width of the highway. We have a kind of data highway, and width of that highway is defined by the frequency band. But we have cars on the highway as well, so the more there are cars, the less there will be space per car. So, what to do? We need to decrease the number of users. How we can do that? We can't eliminate the users as such. Can we move them, say them not to use the system? No, that's not possible. But what this equation tells us is a kind of a capacity or rate within one cell, which is a service unit in the mobile system. If we have smaller cells, then we will definitely have less users there. Okay, but let's go forward. See? Maybe we are going forward. Okay, good. What has been already done is that we are decreasing the cell sizes. Conventionally, we have been playing with very large transmission units called as base station. They cover large areas and large number of users. So if we think about the macro cell, there can be something like 100 active users, or at least 100 users. Now, recently, the cell sizes have becoming smaller, which means that we have less users there, smaller transmission units, cheaper transmission units. In, for example, picocells, we may have something like 20 users. If we go down to smallest cells available, or smallest base station units available in the market, currently the smallest 3G base station is something like 250 grams. It's of course cheaper than a terminal, because it doesn't have fancy screen or anything like that. So with these very small base stations, we have split the system in the tiny cells, overlaid, of course, by these large transmission units. But this is the way how we can decrease the number of users. But we have been doing that already. So what we can still do, if we think about this smallest unit there, femtocell, if we have 4 users there, and in macrocell 100 users, we basically have 25 times more resources per user. But what more we can do? We need we need more bandwidth. And how we find more band? We can go in frequency upwards. Currently, we have most of the communication is carried out in ultra-high frequency, which ends up to 3 gigahertz area. How much we have band there? Something like 500 megahertz in average maybe is available globally. If we go to super high frequency or extremely high frequency, we have much more band available, frequencies available. So if we go even up to extremely high frequencies, there are tens of gigahertz, maybe 20 gigahertz available. If you think about the 20 gigahertz versus 500 megahertz, it's 40 times more. 40 times more frequency resources. And in the last slide, we were calculating that 20 times more resources do the smaller cells. 25 times 40, it's 1,000 times more resources available. Looks very nice. 1,000 times more resources available. But unfortunately, it is not straightforward, because the problem is now that once we go to very high frequencies, we will face very aggressive channel. Basically, we need to see the base station wherever we are. And if I think about, for example, this place, of course, we could use base station in this place, even nowadays. In some auditoriums, I know that there are small base stations used in some other countries, not in Finland yet. But if we go to very complex building structures, outdoors, how we can always reach the situation where user can see base station can see user. It's pretty challenging. We don't need to have that everywhere, but we need to have that places where we need that high capacity. Places where there are lots of people, at least at some point of the day. And I have been just illustrating the situation in building of School of Electrical Engineering. It's not dense enough deployment that I have been plotting there. We should have in every single room a transmission unit. And then there is a small transmission unit actually, which is not a base station, but a remote transmission unit is showed in the picture. It is actually a product that is already available, but not at high frequency, on the current operation frequencies. So tendency is there, but we have a lot of both research work and development work ahead of us. But this was about the technology development. So let's look at the research a little bit. We are doing, in addition to technology research, we are doing analytical, theoretical research to find basic principles for mobile communications. If we think about the analytical methodologies used on the area, the research started from single-link systems, so-called single-link systems. There has been for decades such a research, and these issues has been pretty well studied. Methodology is mature. There is things to do, of course, but I would say that somehow probability for big new steps is maybe small. Then research was flowing towards multi-link systems, where we have few cells, number of users. This research has been ongoing during the last few decades. There has been lots of things done. I have been also participating with that, and there are tons of papers published. Maybe I have been also publishing a few hundred grams. But now, what is maybe missing is the analytical methodology for the network side. So we have been mainly focusing on the link side and multi-link side, but now we need to also tackle the networks that are not uniform. We quite well have methodologies. We have good methodologies for uniform networks, but for irregular networks and pseudo-random or random networks, for random networks we have quite good methodologies, but for pseudo-random and irregular networks we don't have that good methodologies. What is irregular network? It's opposite for regular. But that's all, basically, what most of the people are saying, even in research side. People use a kind of fuzzy term, network topology. They talk about network topology. What is network topology? At least I haven't seen any good mathematical description of network topology that would open a way to analytically study the networks on the radio network side. Network topology is something different on the fixed line networks. But anyway, there is a lot of things to do on that area. Okay, so that's about the research frameworks on academic research side, and then one teaser. When we are talking about any cheese or technology evolution and so on, we usually look at the angle of, I would say, rich society. How technologies would benefit us. But we have been quite a lot of work also on the area of emerging markets. There, the communication problems are truly different. Needs are truly different. Internet or mobile networks are not kind of enablers for Netflix or YouTube, but they are also enablers for many critical issues in life. For example, banking in many African countries is carried out using mobile terminals. This is just an example from Tanzania area where there are tens of thousands of people, no infrastructure, and most of the people do their daily life, for example, banking issues using their terminals. So there is always need for capacity. Broadband internet is not very well working. It's partly out of the reach for a large part of the people. So there is a lot of things to do, and I could ask what these new technologies mean for these people. And finally, while closing, I'm just shortly bringing education on front, because I think that we should also think all the time education. And I have been here for some years, and I have seen how much things have been done in Aalto to improve education. But there is a long way still to go, and we should all put our best effort on education side. So from my side, I give few promises. So I will keep my commitment to teaching. And I have goals to impact in a positive way to students that I guide. I have clear goals for that. But let's let our education be too formal, because that's not a good issue. Okay, good. Thank you.